So welcome back to the construction of there is a torque equation of induction motor. So here this is the rotor resistance and rotor equivalent reactance. Reactance means 2 pi XL2 where 2 pi FL2 XL equal to 2 pi FL. Okay, where here 2 pi F2 L2 where F2 is the rotor frequency. Rotor frequency is slip times of stator frequency. Why? Because we know the slip and the speed are proportional to each other. Why? Because ns is equal to 120 f by p. You have already known this. Okay, synchronous speed formula is 120 f by p. So frequency and rotor speed are frequency and stator speed are proportional to each other. Where f1 is the stator frequency and f2 is the rotor frequency. Okay, and the slip is already discussed. Okay, so frequency of rotor will be decreased. Okay, as an when the rotor gaining momentum means the rotor starts moving. Okay, when rotor is stationary slip equal to 1 and f2 equal to f1. So for us f1 is 50 hertz. For Indian frequencies f1 is 50 hertz, so f2 is 5 hertz. Why? Because our slip value is ranging from 0 to 1 only. Okay, maximum value is 1 and minimum value is 0. Okay, so x2 is equal to 2 pi s f1, f2 is s f1, or you can say x2 is equal to sx2 naught. Okay, and just by rearranging this one and means dividing everything by s, so this become e naught, this become x naught, this become r2 by s. So that is like this. Okay, now the current I2 equal to voltage by impedance r2 by s plus jx2 naught. So I2, so if you rearrange this one in such a way that if you add these two you will get this one. Okay, if you add r2 plus r2 into 1 minus s by s, you will get r2 by s only. Okay, so the right side circuit is replica of the left side circuit. These two circuits are representing same. Okay, so rotor copper losses means this I2 square, I2s square into r2 into 1 minus s by s. Rotor copper loss are I square r. So current I is I2s, R is R2 into 1 minus s by s. So these I square R losses are copper losses in rotor. Okay, where this is stator resistance and stator reactance, rotor resistance and reactance. I2s is starting current and I2s in the next one is running current. SE2 by R2 plus JX2 naught is the running current. Okay. Now after looking all this, see this one. So copper losses are I square R. Okay, see the here. Copper losses are as 3-phase motor. This is a 3 times of I2 square R2, where I2 is this one, and 3 times of I2 square R2 become like this. So PC is equal to copper loss is equal to 3 times of I2 square R2 by S. But the ratio of rotor input P2, rotor copper losses PC, and mechanical power delivered by the rotor is PM is 1 is to S is to 1 minus S. So PC by PM, if you take the ratio, you will get S by 1 minus S. By rearranging the formulas, we will get it. No, don't worry. So PM can be written as like this. Okay. So PM, after substituting this, you will get like this. So on simplifying, PM value become like this. Okay. See here, 1 minus S into 3R2 square into E2 by here I am substituting I2 value as E2 by R2 plus JX2 whole square. Okay. So, but mechanical power delivered by the induction motor is power PM equal to torque into omega. Okay, but omega is 2 pi n by 60. Okay, so PM equal to torque into omega 2 pi n by 60. Substituting these values, we will get like this. Okay, but NR, that N is nothing but NR, rotor speed, that is equal to NS into 1 minus S. Slip value is NS minus NR by NS. By rearranging that expression, we will get this one. N equal to ns into 1 minus, where n is the rotor speed. Okay, so substituting this also here, these two terms get cancelled. 1 minus and 1 minus s get cancelled each other, where ns is equal to ns by 60. Ns is in rps, so that equal to n, capital Ns is in rpm, small ns is in rps. The relation between these two is this one. Okay, so in this way we will get the expression 3 by 2 pi ns, k values. Okay, And the main thing we have to discuss here is we have two torques. One is electromagnetic torque and the other one is load torque. Electromagnetic torque means the torque required, load torque means the torque required to the load. Electromagnetic torque means the torque delivered by the motor. So these two should be matched. Okay. So the torque required by the load should be catered by the torque delivered by the motor. If the load is increased slightly, means what happen? The torque required by the load is more than the torque delivered by the motor. So what happen? The rotor starts reducing its speed. If the rotor reduces its speed,